So, welcome to another session with me, Srilekha, lecturer in mechanical engineering from SRRS Government Polytechnic, Agraharam, Telangana. So, in the previous class, we have discussed various laws regarding the forces. So, we have discussed a system of forces, and later on we have discussed resolution of forces. So, resolution of forces is nothing but splitting or dividing of a single force into two components without changing its effect. So, example we have taken as if F is a force acting at an angle theta with the horizontal, then our horizontal component will be F cos theta and the vertical component will be F sin theta. So thereafter we have discussed composition of forces. Composition of forces is nothing but the combination of two or more forces into a single force without changing the effect of the forces is nothing but composition of forces. So the single force which replaces all these forces is nothing but the resultant of force. Single force which shows the effect of many number of forces acting on a plane or lying in the same plane or different planes is nothing but a resultant. So to find this resultant, in the previous session we have discussed for different cases different formulae that can be used. Like we have discussed for the collinear system, it is simply summation uh, or difference of the two forces to find out the resultant depending upon their unlike or like. And later on we have discussed for the concurrent forces. So we have discussed the parallelogram law of uh, forces. So in that we have discussed that the statement states that this law states that if two forces acting at a point are represented in both magnitude and direction by the two adjacent sides of a parallelogram, then the resultant of the two forces is represented both in magnitude and direction by the diagonal of the parallelogram passing through the same point. Later on, we have also analyzed the parallelogram law of forces. We have derived the equation for the resultant, that is R is equal to under root of p square plus q square plus 2pq cos alpha or 2pq cos theta, where theta is the angle between the two forces. Uh, Hello, welcome to another session of the video lessons by me, Srilekha, lecturer in mechanical engineering, SRRS Government Polytechnic, Agraharam. So, in the previous sessions, all the sessions, we have discussed regarding the engineering mechanics. So, in the first session, we have discussed the measurement, units of measurement, physical units, then force, types of forces, and right now, from the last session, we have been discussing about how to analyze the resultant of forces. So, in the previous class, we have discussed various laws regarding the forces. So, first one was we'll have a small recap of the previous session. So, initially, we have discussed about resolution of forces. So, resolution of force is nothing but the splitting of a single force into two components without changing their effect. So example we can take as, say, if a force F is acting at an angle of theta with a horizon, then this force F, which is inclined at an angle with a horizontal, can be splitted into two components, the horizontal component and the vertical component. The horizontal component would be F cos theta, while the vertical component would be F sin theta. So thereafter we have discussed about composition of forces. So this is something vice versa of the resolution of forces. So if the combination of two or more forces acting along the same plane or different planes but passing through a same point, the, is nothing but composition of forces. So generally this composition of forces principle is used to find out the resultant of forces. So the combined effect of these all forces can be replaced by a single force. So that single force can be called as a resultant. So resultant of forces in different force systems can be found by different methods. So we have discussed for the collinear method, if the forces are passing through the, if they are collinear, then we would add them or we would subtract them to get a result. So in case if they are passing through the same plane, but those are not collinear, then we would take at a point a moment of inertia, moments about a point, and we'll equate them. We feel that it is an equilibrium state, and then we find the reactions at both the ends, and from there we would find missing forces. So those are various types, and we have few laws to find out the concurrent forces. So the first one is parallelogram law of forces. In the last class itself we have discussed. So this law states that if two forces acting at a point simultaneously are represented in magnitude and direction by the adjacent sides of a parallelogram, then their resultant may be represented by the diagonal passing through the two adjacent sides, both in magnitude and direction. So we have also derived the equation for the resultant and also angle of resultant, direction of the resultant. So the resultant direction, the magnitude of the resultant was r is equal to under root of p square plus q square plus 2pq cos alpha, where alpha is the angle between the two forces and p comma q are the two forces. Next, we have discussed the angle made by the resultant, that is theta. So, theta equal to tan inverse of q sine alpha by p plus q cos alpha. And in the previous class, we have also discussed polygon law of forces. So, if number of sides of a polygon are represented by certain forces, then their resultant is represented by the closing side of the polygon. Next, we have also discussed triangle law. If two forces are represented by the adjacent sides of a triangle, then their resultant would be represented by the closing side of the triangle taken in opposite order. So these were the things which we have discussed in the previous session, and in this session we are left over with Lamé's theorem. So this is the only one theorem that we have left over for finding the resultant of the forces, and one more is there. So next we have to discuss about the equilibrium and equilibriant, which we will be discussing in the next session. So now today's our topic is resultant of forces. So Lame's theorem. So it states that if three forces acting at a point are in equilibrium, each force will be proportional to the sine of the angle between the other two forces. So once again, it is very simple as it is. If three forces are acting at a point are in equilibrium, then each force will be proportional to the sine of the angle between the other two forces. So here you can see there are three forces P, Q and R. P is represented by red color, Q is represented by black and R is represented by cyan color. Say if these are the three forces which are passing through the same point O. Now if you see angle made by P is nothing but the included angle of Q and R, that is alpha. Similarly, angle made opposite to the Q is beta, that is between R and P, and similarly the angle opposite to R is gamma, that is between angle included between P and Q. Now according to Lame's theorem we can write that, so we know that force by sine of opposite angle is proportional. So P by sine alpha is equal to Q by sine beta is equal to R by sine gamma. So this is our Lame's theorem. It is very simple to apply as well as to remember and understand. So P by sine alpha is equal to Q by sine beta equal to R by sine gamma, where P, Q and R are the forces and alpha is the angle between R and Q, beta is the angle between P and R and gamma is the angle between Q and R. So let us discuss some problems related to parallelogram law and also Lame's theorem today. So let us go through this. So find the magnitude and direction of the resultant of two forces of 80 newtons and 40 newtons acting at a point if the angle between the two forces is 45 degrees. So what all can we understand from the problem is that, so it is given that first force P is 80 newtons and second force is 40 newtons and angle between the two forces, that is alpha, is equal to 45 degrees. Now we need to find resultant, magnitude of the resultant R and direction of the resultant, that is nothing but theta. So we already know the formula for that. R is equal to under root of P square plus Q square plus 2PQ cos alpha. That is what we have substituted in place of P 80 and Q 45 and alpha 45 degrees. On substituting, we will get 111.92 newtons. Next, direction of the resultant. We know the formula for this as theta equal to tan inverse of Q sine alpha by P plus Q cos alpha. So that is equal to, you will get the answer on substituting Q sine alpha by P plus Q cos alpha. You get the value 0.26212 and tan inverse of that term with PQ 14 degrees 38 seconds. Next one. Two unequal forces inclined to one another at an angle of 120 degrees have a resultant of 86.6 newtons, which makes an angle 30 degrees with one of the forces. Find the magnitude of two forces. So, what all we can understand? So, two unequal forces. It means both the forces are not equal. P and Q are not equal. And they are making an angle of 120. Means alpha is equal to 120 degrees. And the resultant is 86.6 newtons. And this resultant is making an angle of 30 degrees with the horizontal. Okay. So theta is equal to 30 degrees. Now we have to find both P and Q. So we know so in the given data, theta is given and alpha is given. So 120 and 30. So we can use direction of the resultant formula. Direction of the resultant formula. So for this, what all we do is what all we can do is simply substituting theta, simply substituting theta is equal to tan inverse of tan inverse of q sine alpha by p plus q cos alpha. Okay. So this is the formula we are using, and so on substituting, so tan theta equal to q sine alpha by p plus q cos alpha. So you know that theta is equal to 30 degrees. So q you don't know and p you don't know. So sine theta value we know. So from this we'll get the equation p is equal to 2q. Thereafter we know the one more formula, that is resultant r. So r is equal to under root of p square plus q square plus 2pq cos alpha. So I'm substituting those, and instead of P I am substituting 2Q. You will get the value Q is equal to 50 newtons and P is equal to 100 newtons. So this is all the solution for the above problem. Next, third problem. So three forces acting in a particle are in equilibrium. So angle between first two forces is 90, and then between the second and third is 120. Find the ratio of the forces. So here it is given three forces acting on a particle are in equilibrium. So this means that, so this is not related to a parallelogram law of vectors. So if it is parallelogram law, they'll give the two forces and they'll speak something about the resultant. In this they have given three forces. So we have to make a note that this is related to the Lamis theorem. So angle between first two is 90 and second and third is 120. So let us take, so let first force be P, second force be Q, and third force be R. So angle between P and Q is 90 and Q and R is 120. So as we know, the angle of rotation or angle of revolution is 360 degrees. So to get the angle between P and R, we have to simply take 360 minus of 120 plus 90. So 120 plus 90 is 210. So 360 minus 210 is simply 150 degrees. We know that according to Lamis theorem, P by sin alpha equal to Q by sin beta equal to R by sin gamma. So therefore, P by sin 120 is equal to Q by sin 150 is equal to R by sin 90. So P by Q is equal to sin 120 by sin 150. So you can simply equate any two. So either you can take P by sin 120 equal to Q by sin 150. Next you can take Q by sin 150 equal to R by sin 190, and then P by sin 120 equal to R by sin 90 degrees. If you take three equations, you can get all the values. So on equating first two, P by sin 120 equal to Q by sin 150, you will take P by Q equal to 1.73. Next, so for second, Q and R I am taking Q by sin 150 equal to R by sin 90. I am getting 0.5. So if I take P is equal to X, then Q equal to X by 1.75, R equal to 2X by 1.73. So P is to Q is to R, if I take X is to X by 1.73 is to 2X by 1.73. Out of this, X is common, so omitting off. So left over will be 1 is to 1 by 1.73 is to 1 by 1.73. I'm multiplying and dividing with 1.73. So what happens? 1.73 at the denominator sides of two forces will get cancelled, and the leftover thing would be 1.73 is to 1 is to 2. So this is the ratio of the forces. 1.73 is to 1 is to 2. So this will be our answer. Next, I am taking one more problem, that is an electric light fixture weighs 30 newtons hangs from a point O by two strings OA and OB as shown in the figure. So find the forces in the strings. So in the string A and B we need to find the forces. So it is given that the angle made at the vertical with A is 45 degrees. Now angle made at the horizontal at B is 60 degrees. Now we are going to resolve the forces. So what data is given, first let us take. So weight of this light W is equal to 30 newtons. You can take this as P. Next, Q and R are not given. So let Q be tension in the wire A. Let R be tension in the wire B. Now if I take the angles at the included angles here, then I can easily find out the values. So T1 is the tension in the string A, T2 is the tension in the string B, and W is the weight of the fixture, applying the Lami's theorem. So see here, I have done a simple calculation part. Now, if I draw a vertical line projecting from this weight, so you can see that light is hanged by a straight line. So if I draw this upwards, so what will be the things left over will be, see, if I draw it upwards, on the right side we'll have 30 degrees, on the left side we'll have 45 degrees. So 30 plus 45 will be 75 over there. And again at the downwards, so here already 45 went. So the remaining the left side part will be 180 minus 45. And on the right part it will be, so there we have lost 30 degrees at the top. So here it will be 180 minus 30 degrees. So the angle between A and B wires will be 75. So A and the electric light will be uh, it will be 135, and electric light and the wire B will be 150. So simply by applying this Lami's theorem, we can write W by sine 75 is equal to T1 by sine 150 is equal to T2 by sine 135. So T1 is equal to, so already we know that W is equal to 30 newtons. So 30 into sine 150 by sine 75, that is equal to 15.53 Newton. So tension in the wire A is 15.53 Newtons. Tension in the wire B would be 21.95 Newtons. Next problem related to the Lami's theorem. A weight of 2 kilonewtons is supported by two strings as shown in the figure. Find the tension in the springs. So here you can see a load is hanging downwards, and this load is tied by means of two strings, that is A and C. So here again same, the load is of 2 kilonewtons and the angle is, again we have taken, it is 75 degrees and 180 minus 30 degrees and 180 minus 45 degrees. Simply finding the uh, finding the included angles, it is very simpler to do. So W by sine 75 is equal to T1 by sine 150 is equal to T2 by sine 135. So on substituting W is equal to 2, you will get T1 is equal to 1.035 kilonewtons and T2 is equal to 1.46 kilonewtons. So thus we have calculated few problems related to Lami's theorem, and also few problems related to parallelograms theorem today. So today we have discussed about the Lami's theorem and the application of Lami's theorem in various problems. So this is all for today.